students, today we are going to see the problems involving in geometry and locus of complex numbers. So exercise 2.6, first problem. If z is equal to x plus iy is a complex number such that modulus of z minus 4i divided by z plus 4i is equal to 1. Show that the locus of z is real axis. Okay, I'll consider the term what is given. So which is equal to 1. Okay, so modulus of z1 by z2 can be written as modulus of z1 by modulus of z2. So it will be modulus of z minus 4i divided by modulus of z plus 4i. So in the denominator, modulus of z plus 4i into 1, it will come in the right hand side. Okay, so it is given that z is equal to x plus iy. So I have taken let z is equal to x plus iy. In the place of z, I have substituted x plus iy. Okay, here also in the right hand side also, in the place of z, I have written x plus iy. Okay, so first what you have to do, you have to group the real part and the imaginary part. Here x is the real part, and from these two terms what is common? I is common. So when I take out I, so the remaining is y minus 4. The same way here also x is a real part plus I into, from these two terms I have taken I is out, so the remaining is y plus 4. So we have to remove the modulus. So how to take modulus of any complex number? It is nothing but square root of real part the whole square plus imaginary part the whole square. So here it is the real part is x, so x squared. What is the imaginary part? Y minus 4. So y minus 4 the whole square. In the same way here also I have taken the modulus of this complex number. Okay, so squaring on both the sides, you will get the square root getting cancelled on both the sides. So the remaining term is x squared plus y minus 4 the whole square is equal to, here also x squared plus y plus 4 the whole square, and the x squared getting cancelled. When you expanding this using the formula a minus b the whole squared, you will get y squared plus 16 minus 8y. Here you are going to use a plus b the whole squared, so it is y squared plus 16 plus 8y. So y squared getting cancelled, 16 getting cancelled, minus 8y, when I take it to the right side it is plus 8y. So already 8y is in the right side, so 8y plus 8y is 16y is equal to 0. So 16y is equal to 0 means y is equal to 0. Y is equal to 0 is nothing but, in this complex number, if y is equal to 0, z is equal to x. Okay, z is equal to x means the locus of z, all the points, okay, is nothing but real axis. Okay, come to the second problem. If z is equal to x plus iy is a complex number such that imaginary part of 2z plus 1 divided by iz plus 1 is equal to 0. Show that the locus of z is this equation. So I have considered the term what is given here. Imaginary part of 2z plus 1 divided by iz plus 1 is equal to 0 is given. From that I have taken only this 2z plus 1 divided by iz plus 1. In that I am going to substitute z is equal to x plus iy. So 2 into x plus iy plus 1. Here I into x plus iy plus 1. Okay, the 2 has to be multiplied with both the terms. So it will become 2x plus 2iy plus 1. So when you multiply I into x's, it is ix. I into iy is I into I squared. I squared value is minus 1. So minus y plus 1. So here what I have to do? I have to group the real part and the imaginary part. Look at this. 2x plus 1 is the real part, and 2iy, you are getting the imaginary part. In the same way, here you are having minus y plus 1. That can be written as 1 minus y. Both are same. Minus y plus 1. Here I have written 1 minus y plus ix. So it is not in the rectangular form. So what you have to do? You have to multiply and divide by the conjugate of the denominator. So conjugate means what you have to do? You have to replace I by minus I. So I am going to take the conjugate of the denominator and then multiply and divide. So the conjugate of the denominator is 1 minus y minus ix. So here I have multiplied and divide by that. Okay, look at this. The denominator. Okay, so how it is in the form of z into z bar. So z bar, the formula is real part the whole square plus imaginary part the whole square. What is the real part? 1 minus y. So 1 minus y the whole square plus what is the imaginary part? X or minus x. When you square it, it is x square. So it is in the form of z bar. So the answer is real part the whole square plus imaginary part the whole square. And I am going to multiply these two complex number. Okay. So see that what is given, that only the imaginary part of this complex number is equal to 0. Okay, what is given, that the imaginary part of this complex number is equal to 0. Okay, so 2z plus 1 divided by iz plus 1. What we have obtained? We have obtained for that. Okay, so here in this you have to find the imaginary part. You have to find the imaginary part. Okay, you need not multiply the whole complex number. Here you want only the imaginary part. But how to find the imaginary part of product of two complex numbers? So already it is explained in the multiplication of two complex number. Listen now, here we want only the imaginary part of this complex number. Okay, only the imaginary part. For that, what you have to do? You have to take the real part of the first number. It has to be multiplied with the imaginary part of the second complex number. So 2x plus 1 has to be multiplied with minus x. So I have written the first term of the imaginary part. Next, you have to take the imaginary part of the first number. It has to be multiplied with the real part of the second number. So here it is 2y has to be multiplied with 1 minus y. So it is a common denominator. So you have to write it. Here I got only the imaginary part of this complex number. So what is given? It is equal to 0. So which is equal to 0. The denominator, when you take it to the right side, it will become 0. Okay. So you will get this term. So you have to multiply. So 2x into minus x is minus 2x squared plus 1 into minus x is minus x. 2y into 1 is 2y. 2y into minus y is minus 2y squared, which is equal to 0 divided by minus 1. So it will become 2x squared plus 2y squared plus x and minus 2y. So the locus of z is 2x square plus 2y square plus x minus 2y, which is equal to 0. So we'll go to the third problem. Here, obtain the Cartesian form of the locus of z is equal to x plus iy in each of the following cases. Okay, here there are 4 subdivisions. You look at this. Real part of iz the whole squared is equal to 3. So we have taken z is equal to x plus iy. So you are going to find first iz. So I into x plus iy. When you multiply, it will become ix into I into iy. So it is I squared y. I squared is minus 1. So you will get minus y. Here what is given? Real part of iz. So iz I have found here. Which is real part of iz is? Real part of iz is minus y. Okay, so you have to substitute in this condition. What is given? That real part of iz the whole squared is equal to 3. So what is the real part of iz? What we have found, it is minus y. So minus y the whole squared is equal to 3. So it will become y squared is equal to 3. Come to the second subdivision. It is imaginary part of 1 minus I into z plus 1 is equal to 0. So first let z is equal to x plus iy. You take this term first. So what is it? 1 minus I into z plus 1. Okay, so 1 minus I into x plus iy. In the place of z, I have substituted x plus iy plus 1. So what you have to do? You have to multiply these two complex number. How to take the product of two complex number? First you have to write the real part, then you have to write the imaginary part. So to write the real part, what you have to do? You have to multiply real part into real part. 1 into x is x. In the same way, imaginary part has to be multiplied and then change the sign. So here minus 1 into y. Minus 1 into y is minus y. While you are changing the sign, it will become plus y. So we have written the real part. plus I into, you have to go for the imaginary part. How to write the imaginary part? Real part of the first number, it has to be multiplied with the imaginary part of the second number. So 1 into y is y. In the same way, minus 1 into x is minus x plus 1. So what we have found? We have found the term 1 minus I into z plus 1. Okay, so here you have to group the real part and the imaginary part. So x plus y plus 1, it's a real part, plus I into y minus x. Okay, in this, what is given? The imaginary part of this complex number is equal to 0. We have found the complex number here. Which is the imaginary part? The imaginary part is y minus x. That only equal to 0. So, imaginary part of this complex number is y minus x. That is equal to 0. So, you are getting y is equal to x. Next one. It is given like that. So, in the place of z, you have to substitute x plus iy. So, here it is x plus iy plus I, which is equal to, here in the place of z, x plus iy minus 1. So, you have to group the real part and the imaginary part. So, x here you are having, in these two terms you are having I is common, so it is taken out, remaining is y plus 1. In the same way, here you look at this, x minus 1, it has to be grouped as a real part, plus iy. Okay, so this term is written within the modulus. So while you are using modulus of any complex number, it is nothing but square root of real part the whole square plus imaginary part the whole square. The same way here also I have used the modulus of the complex number formula I have used. Okay, both the sides square root is there. So to remove the square root, you have to squaring on both the sides. So you will get the answer x squared plus y plus 1 the whole squared is equal to x minus 1 the whole squared plus y squared. Okay, so when you expand, it is x squared. It is in the form of a plus b the whole square. So a squared plus b squared plus 2ab. Here it is in the form of a minus b the whole square. So it is x squared plus 1 minus 2x. A squared plus b squared minus 2ab plus, here you are having y squared, so I have written the y squared. You look at this, x squared is getting cancelled, y squared is getting cancelled, and plus 1 is getting cancelled. So minus 2x, when you bring it to the, so you are getting 2y is equal to minus 2x. So the minus 2x, when you bring it to the left side, it will become plus 2x. So 2x plus 2y, which is equal to 0. So when it is divided by 2, you will get the answer x plus y is equal to 0. Come to the next one, fourth one. It is given as z bar is equal to z inverse. So substitute z is equal to x plus iy. Okay, so you just consider the term. In the place of z, you have substituted x plus iy. So x plus iy the whole bar, which is equal to x plus iy the whole inverse. Okay, so you have to write the conjugate. Conjugate means replace I by minus I. So it is x minus iy. So how to write the inverse? It is nothing but 1 by z. Z inverse is nothing but 1 by z. So 1 by x plus iy. So when you cross multiply, you will get this answer, which is equal to 1. How it looks like? If it is z, this is z bar. So z bar oda formula, what it is? Real part the whole square plus imaginary part the whole square. So which is equal to 1. This is the locus of z. Thank you, girls.